Okay guys, today we're starting to look at trapezoids. This is going to be a big section, a lot to get through. It's going to be split into two videos and I'm going to go pretty fast. Let's start by what is a trapezoid. A trapezoid is a quadrilateral, 4 sides, with exactly one set of parallel sides. Okay? We got a parallel side there and a parallel side there. You can use the first box on your notes for this. Okay? So again, the definition, a quadrilateral, 4 sides, with one set of parallel lines. Okay? Contrast that to a parallelogram. On a parallelogram, we had to have 2 sets of parallel lines. Okay? That's our first big difference. All right. A little more definition. Stay on the same shape. These 2 sides that are parallel are called the bases. The ones that are not parallel are called the legs. All right? Simple definitions. Let's look at a few more properties of these quadrilaterals. And I'm going to need to drop my eraser, sorry. Let's draw something similar to the second box on your nose. Okay, pretty close. All right, we have a parallelogram. Not a parallelogram, a trapezoid. Okay, trapezoid, one set of parallel lines. There is a special case of trapezoids called an isosceles trapezoid, and it means this. If we're given that this leg and this leg are congruent, both of our legs are congruent, it's what's called an isosceles trapezoid, okay? Isosceles trapezoid. Okay? An isosceles trapezoid has some very unique properties. Let's start with the angles. Okay? It turns out that if we have an isosceles trapezoid, this base angle, okay, the angle by this base angle are going to be congruent. Same measurement. Also, those 2 angles, those 2 base angles are congruent, okay? Contrast that to parallelograms. On parallelograms, the opposite angles were congruent. That's not what happens here. The base angles are the ones that are congruent, okay? All right, let's look at another picture. Go down one more example on your notes. Okay? Redraw my trapezoid here. All right. Well, it turns out that if I'm given a trapezoid, and I'm also given one more piece of information. Let's say we're given that one of the sets of base angles are congruent. Let's say we're given that those 2 are congruent. It could have been these 2. It turns out that if it's a trapezoid with one pair of base angles congruent, it will be isosceles, okay? This is enough information to determine that it is isosceles, okay? We can then say for sure that this side and this side are congruent, okay? That's one of the tests. Let's go down one more and look at one more property of these isosceles trapezoids. Let's redraw here a little bit. Okay, let's look at what happens with the diagonals. Well, it turns out that the diagonals of a trapezoid, if it's an isosceles, are going to be congruent. Okay? So here's what we're saying. We're saying from here to here and from here to here are the same distance. Okay? These are not bisectors. Okay? On a parallelogram, the diagonals would be bisectors, meaning this distance and this distance would be the same. That is not what happens here. Okay? And again, this only applies to those isosceles trapezoids. I should put little marks there. This is an isosceles. But there is something unique that does happen with these diagonals. It turns out in an isosceles trapezoid, this side and this side are congruent. This side and that side are congruent. Okay? Contrast that to parallelograms. Think this through for a minute. It's not a bisector because this side and this side are different. Okay? But we still do have this side and this side being congruent. Okay? Think through that a little bit. Make sure you understand the difference between a trapezoid and a parallelogram. All right, let's look at an example here. How we can apply that information, some of the problems we'll have on our homework. All right. So we're given this trapezoid. Okay? WXYZ. It is a trapezoid, one set of parallel lines, and it is isosceles because the legs are the same. We're given certain pieces of information. And let's just start filling it out. YZW. YZW, that angle altogether is 45 degrees. Okay? That whole angle there is 45 degrees. Okay? We are also told that WV is 15 and VY is 10. All right. What do they all want us to find? First, they want us to find XWZ. XWZ. What does that angle measure? Well, if it's an isosceles, the base angles will be the same. So this side and this side must be congruent. So, we can state that this also must be 45 degrees. That would be your answer for A. Let's look at B. WXY. WXY. Well, the base angles are congruent, not opposite angles, so it's not 45, but we got to pull some other information here. First of all, a trapezoid is a quadrilateral. So we know that the four angles of a quadrilateral add up to 360. Okay? Well, if this one is 45 and this one is 45, we've already used up 90 degrees. Okay? So we see that we have 270 degrees left between these two base angles. If they're congruent, and they are because it's isosceles, we take 270 divided by 2. So that gives us 135 degrees. Okay, 135. Okay? Also, even though we don't necessarily need to answer it, but just to illustrate, this angle right here would be 135 degrees. Okay, let's look at some segments. Next, we want to find XZ. XZ, that whole length. Well, we know that the diagonals are congruent. WY, well, we know this is 15 and this part is 10, so all of that is 25. So obviously, this whole distance has to be 25. So XZ equals 25. Okay, that would be our answer for part C. The last thing it wants to know is XV. XV. Well, what is congruent to XV? We should be able to see right away that this part of the diagonal is congruent to this part. So XV must be 10. Okay? All right, you'll have several problems like that on the homework. It'll be on the test, so be ready for it. Make sure you understand it. All right, let's go to the next page, and we start dealing with coordinate geometry. I know I've thrown a lot at you on trapezoids. We need to push through this and get through coordinate geometry. Let's take this down. Okay, and let's look at this example problem here. Quadrilateral QRST has the following vertices. Notice that I wrote these out in a clockwise direction here, okay? Q, R, S, T, okay? So here's what we can do though. We want to determine if this makes a trapezoid. And I did some of it so we could find diagonals if we wanted to. Here's what I want you to do. This will be the last part of this video. The answer will be on the next one. Find the slope of each set of these. So you're going to find the slope for QR. You're going to find the slope for RS. You're going to find the slope for ST and the slope for TQ. Okay? That is the slope of this line, this line, this line, and that line. Okay? Find the slopes. You should get one set of parallel slopes. We'll look at the test for isosceles on the next video.